Hi, my name is Maggie. Today I am going to present Dijkstra algorithms. What is Dijkstra algorithms? Dijkstra algorithm used for finding the shortest path from starting vertex to target vertex in a weighted graph. Other words, it calculates the shortest path to every vertex in weighted graph. The approaching is a greedy algorithm. The input, the weighted graph with edges and vertices, and the source vertex, such that all edges, weights are non-negative. The output is we deliver the length of the shortest path from a given source vertex to all other vertices. The conditions, it works only for the connected graph. It requires non-negative weights on all edges. It only provides the value or cost of the shortest path. It works for directed and undirected graphs. Some of its applications are used for social networking, finding the shortest distance on the map, telephone networking, IP routing to find the first shortest path, and more. From this example, we can clearly see that the shortest path from A to D is A, B, C, D. It means if A, B, C, D is the shortest path from A to D, then the shortest path from B to D must be B, C, D, and the shortest path from A to C must be A, B, C. Other words, any subpath from B to D of the shortest path A to D between vertices A and D is also the shortest path between vertices B and D. Dijkstra algorithm also use this property to track back the shortest path in the opposite direction after overestimating the distance of each vertex from the given started vertex. Let's look at this example, positively weighted and directed graph. The question is, we looking for the shortest path between the vertex A and all other vertices of this graph in this example. First of all, we always initialize the source A with 0 and initialize all other vertices with an infinity distance and an unknown predecessor. The idea of this algorithm is to continuously eliminate longer paths between the starting vertex and all positive destinations. To keep track the process, we always need to have two distinct sets of vertices, processes and unprocessed. Processed vertices are ones with the estimated minimum distance and predecessor are filled and finalized. Unprocessed vertices are ones can reach from the source, but minimum distance not finalized. In this example, we pick the lowest distance and then evaluate all its unprocessed adjacent vertices. The idea is to add the edges weight from its adjacent vertex to the source distance, then compare it to the destination distance. For example, vertex B is equal 0 plus 2. Is lower than the infinity. The new distance for the vertex B is 2, and the new predecessor is A. The same applies to vertex C. Vertex A is now processed. Vertex B and C are added to the unprocessed vertex. Because they can be reached from the source, but we still need to process their adjacent vertices and make sure that the distance we pick are the index minimum. Now that we have two vertices in the unprocessed set, which are vertex A and vertex B, we choose the one with the lowest distance. In this case, we choose vertex B. Then we reiterate the same process until we process all vertices in the graph. Now we check the adjacent vertex of B. We take C. Vertex C is equal to 2 and plus 3, so it's greater than 4. Then edges way from B to C added to the minimum distance of B is bigger than the previous distance of C. Therefore, the distance of C we have is minimum, and we don't update the C. After repeating this process on all the available vertices, we will be able to calculate the minimum distance and path from vertex A to all of the graph vertices. Let's do the implementation using table. Before we start using the table, we need to know that we always start at the source vertex. And there are two steps. The base step is initialize the table with set the value of the starting vertex to 0 and all other value to infinity. The recursive step, basically, we update the estimate and then we pick the next vertex with the least values. Now let's do Dijkstra algorithm using table. This is a undirected and weighted graph. And the question is, what is the shortest path starting from vertex A to every other vertex in this graph? So we start from vertex A. The base step for Dijkstra algorithm, the base step is using table is initialize the table. So A, start from A to A is 0. And from now, every vertex is infinity because we're not explore yet. So now we know they are all infinity. So we start from A, we can go to B and can go to C. A to B is 3 and A to C is 6. So this row we explore A to A is 0. I copy down. And then A to B is 3 from A. And A to C is 6 from A. I cannot go to D, E, Z from A. So they are still infinity for now. So recursive step is update and estimate. We already did that. And now to the next vertex to process. So between these two vertex, we should choose the smallest value vertex. So it should be B. So now we explore B. I copy this value down, that 3 from A, and then I box it. So which means we already processed this vertex and it is finalized 3. From B, we can go to D, we can go to C. B, go to D is 11 from B. So same thing to C, can have C can have 5, but 5 is smaller than 6. So I'm going to update this. 5 from B. From B, I cannot go to Z, I cannot go to E from B. So the two are still infinity. So now between the two vertices, C has smaller value. So I'm gonna choose C. So I copy down the value, smaller value for now. I box it so it's already processed. So we now doing C. So from C, I can go to D, I can go to E. C to D, C right now is 5 to D plus another 4, so it's going to be 9 from C. And then C can go to E, so it's going to be 8 from C. C cannot go to Z, so it's still infinity. So between the two vertices, A from C of vertex E should be choose. So I copy down A from C for E. Now we explore E. E can go to D, E can go to Z. E go to D is 8 plus 2 is 10. 10 is bigger than 9, so we don't want to update this value. So I just copy 9 down here, still from C. And E can go to Z. E go to Z is A plus another A, so 16. 16 from E. Okay. So now between D and Z, D has smaller value, so we should choose D. So now we explore D. And I copy down the value 9 from C here. So D, we can go to Z. D to Z, D right now is 9 to Z is plus another 4 is 13. 13 is better than 16. So we update this from D. So now we're done. And you know that Dijkstra algorithm, we can track back to find the path that we already went, that we already found the shortest. So we can draw the span in tree to see the path that we can drag back. So we drag back from D. No, actually we drag back from Z. But Z from D. Z from D. So we have D here. So we have Z 13. So we go back to D. D we have 9. We got 9 from C. C we have 5 from B. From B we have 3 from A. A we got 0. So we got almost every vertex. And then we don't have the E from C. E, we got the 8 from C, so it should be E right here. And then we have A. This is the algorithm using priority queue. And this is a summary step of algorithm. We always maintain the path distance of every vertex and store that in an array of size V, where V is the number of vertices, and be able to get the sorted path, not only the length of the sorted path. For this, we map each vertex to the vertex that last updated its path length. Once the algorithm is over, backtrack from the destination vertex to the source vertex to find the path. A minimum priority queue can be used to efficiently receive the vertex with the minimum path distance. And this is the pseudocode. And this is the code using priority queue in Java. Time complexity. Where E is the number of edges and V is the number of vertices. The implementation is to store vertices in an array or linked list. This will produce a runtime of big O of V of power 2 plus E. For graph with few edges and many vertices, it can be implemented more efficiently, storing the graph in the adjacency list using binary heap or priority queue. This will produce a running time of big O of E plus V and log V. Using priority queue for the complexity of the algorithm from big O of V power 2 to big O of E plus V log V. This is the graph that illustrates the running time comparison between 6 variants when the number of vertices is increased. For more detail about the comparison of running time, you can go to this source and read the article. Here are the sources that I have learned from. And that's it.